All right, hello everybody. Welcome to May 5th, day 9 of Sound and Light. So your job today is to complete the notes presentation today and do our exit ticket by 2:30. All right, so we're on day 9. Hopefully everything is posting together, so it's only one post, so you'll have the slides and the exit ticket all there together. And then if I don't have them in yet already, I will put the exit ticket in here at the end of the video. So today we're specifically going to be talking about the electromagnetic spectrum of light. So everything from radio waves down to gamma rays and how they actually interact with other things. So electromagnetic radiation or electromagnetic waves are waves or of oscillating electric and magnetic fields that move at the speed of light. So electromagnetic waves are light waves. Now there's lots of different parts of light waves. Radio waves are technically light waves. So are gamma rays, X rays, microwaves, and then there's the light that you and I can see, right? The red, orange, blue, indigo, yellow, green, violet, all of those colors, all right, are also light. So that along with X-rays and infrared and UV, right, those make up the electromagnetic spectrum. And they're all moving at the speed of light. So really, 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 really fast. Um, so anything that creates oscillating magnetic or electric fields will create electromagnetic waves. So if we ever, there's lots of different things that will create these. And really radio waves even start at about 3000 hertz. There's lots of different things that can occur with this. So what is light? Light is all forms of the electromagnetic spectrum. When we talk about light, we talk about the speed of light, right? You probably heard Buzz Lightyear, light year. What is a light year? What is the speed of light? All that different stuff. So the speed of light is how fast it actually travels. We use the variable c. Don't ask me. You guys figured it out a long time before me who knew a lot more about it. But if you've ever heard the famous equation E equals mc squared, or energy equals mass times the speed of light squared, that's where it comes from. And all electromagnetic light travels at the same speed. So a radio wave travels as fast as a gamma ray, but there's some differences in their wavelength and their frequency. So that speed of light is 3 times 10 to the eighth meters per second, or 300 million meters per second, or 669 million, um, 669 million miles per hour. It's just really fast. 186 miles per second. And it travels in a straight line. And that's why all of this stuff, you guys will see light traveling through space takes like roughly 8 minutes for light from the sun to get to Earth. It travels really, really, really fast. It carries energy, color. It can also carry information that talks. If you've ever seen like fiber optic cable or have heard of that, that's part of the deal. And then it can actually change matter when it interacts with it. So if it's absorbed by matter or if it's transmitted through matter, it can actually change what's going on there. It does act, it's a little bit tricky and it's not completely um, understood at our level of what light really is, but it can act like a particle that we call a photon. So it can act like one little piece of light. It can also act like a wave that just moves up and down, up and down, up and down. So, what is a photon? We call it a massless bundle of light energy. So, it's just a little particle of energy, and it's the smallest quantity of light. So, one photon is the smallest piece of light that we can get. Light with high energy photons. This means these things are really strong and really powerful, are things like gamma rays, X rays, UV, act more on particles. If you guys think about UV light is what gives us sunburns. So UV light will actually kill the cells in our skin, and that's what's happening when you get a sunburn. X-rays can actually see through our skin, right? If you've ever gotten an X-ray, they go through the soft tissue and only are absorbed by the heart tissue, and that's why you get an image like an X-ray. And gamma rays are really dangerous. They're used to do some really intense sterilization for medical equipment. You can use gamma rays to get all of the bacteria off of it or kill it, and then you have to scrub them to get them off. But it will kill just about anything. If you're a superhero person, gamma rays created the Hulk. Like gamma rays are really, really strong and really, really dangerous for you. Um, what they actually do at that point is they have enough energy to rip the electrons off the atom and then break the bonds with inside of that atom. In our next unit, we talk more about the atom and chemistry of how they're built together, but that's something that's really bad. If if an atom starts to fall apart, that's really bad because then all of the properties of that atom change, and then whatever that object is, whether it's a protein or it's a fat or carbohydrate, whatever it is in your body, it's not going to be able to do that same job, and it's not going to be able to fit together with the other pieces like it's supposed to. Light with low energy photons, these ones are going to be harmless to us. These things are like radio waves, infrared, and visible light. So you and I see all the different colors of the rainbow in different mixtures throughout the day. Radio waves are passing through, your home right now as we speak. They're big. They're really long wavelengths. Infrared are used in a lot of remote controls. There's even some that use UV light. There's some cool tricks if you have a Samsung phone that you can do with your camera and UV light. You can figure out if you have an infrared or a UV remote control for like your TV. But visible light with really low energy photons, they really do act more like waves. They're usually the big, long wave type of waves. That's scientific. All right, so your job is to complete the exit ticket for today. If I look at it, your exit ticket for today, there's a video um, on the slides there. Uh, List 8 facts from there, and then make the note from the notes. Make a list of 6 properties of light. All right, have a great day, everybody. And if you have any questions, please reach out. Remember, you have a mandatory check-in. This is going to be a 5 minute to see how you're doing, kind of check in, but sign up for that. And I'll see you guys later. Have a great day.